Hello, welcome back to Math 121. This is a video over section 3.6. We're going to be talking about polynomial and rational inequalities. Okay, so in this, remember an inequality is when things aren't equal. Okay, so inequality means that things are not equal. Okay, and quantities are larger or smaller. So larger quantity, let's write that out. Quantities are larger or smaller, okay, than one another, okay? And so let's kind of talk about this. And let's go over our objectives. We want to be able to solve polynomial inequalities and rational inequalities, and then solve problems modeled by polynomial or rational inequalities. So what I want to do is, let's do this. Let's just think of something simple, okay? Let's think of y squared, or not y squared, let's think of x squared, okay? Something simple. A parabola is greater than or equal to 1, okay? Let's just think of something simple. Now, let's just quickly look at a graph of this real quick, okay? What I'm going to do when I graph this is I'm going to graph the line y equals x squared, and then for here I graph y equals 1. Okay, so when I'm graphing these, okay, to do this graphically, and that's kind of the thing, is that we'll be able to use our calculators, we'll be able to graph this, but we want to be able to understand what we're doing when we look at a graph. Okay, so let me graph those real quick and get that up here. Okay, so I've graphed those in Desmos, and what you see here is that you have the graph of x squared and you have the graph of y equals 1. Okay, now what we're trying to figure out is when is x squared greater than or equal to 1? And what I'm going to do is I'm going to highlight that here in green. Okay, so my graph is larger than or equal to 1 at these endpoints here and here, and that's what we got. Now, if I'm talking about the intervals at which this is true, okay, what I'm going to do is this. All right, so my solution to this problem is as such. Okay, I would say that this goes from, and let me just kind of highlight this on the graph as well. Okay, I know that we are larger than 1 from the intervals from negative infinity to negative 1, and then from 1 to positive infinity. Okay, so I'm just showing you where this occurs on the x-axis. Okay, that's what we're looking for. So my solution would be this. We go from negative infinity to 1, okay, or I'm sorry, to negative 1. Okay, include negative 1 because we're greater than or equal to. And then we union that going from 1 to positive infinity. Okay, we include 1, and we go to positive infinity. This is my solution. This is when my graph is greater than or equal to 1, all right? And so that's what we got, all right? And that's what we're doing, okay, is we're identifying those intervals at which this is true. Now, what I want to do, this is the graphical method, okay? But what I do want to do is show you algebraically how we do that, okay? So here's what I'm going to do. I'm going to consider, okay, just the equation x squared equals 1. Okay, we can solve this a couple different ways. So all I've done is I've taken away my inequality and I've put an equal sign. Okay, so I'm going to consider that equation. We can solve this a number of ways. I could subtract 1 from both sides and we get x squared minus 1 is equal to 0. This factors to x plus 1, x minus 1, and that's equal to 0. So I set each of my factors equal to 0. So I get x plus 1 equals 0. And I get x minus 1 equals 0. So subtract 1 from both sides. I get x equals negative 1. And then add 1 to both sides. And I get x is equal to positive 1. All right. So those are my values. All right. And what I'm going to do now is create a table, okay? And in my table, all right, my top part is my interval, okay? My next column is my test point. And then my third is my conclusion, okay? And so my interval, these goes from negative infinity to negative 1. I go from negative 1 to 1, and then I go from 1 to infinity. Now, how I'm getting this is I'm just using my numbers, okay? These are what I call, when I get these answers, when I solve this equation, I'm going to call these critical points, okay? And on these critical points, those are the points at which I know that it's going to change from being, above the graph or below the graph, okay? And that was these points here, okay? So negative 1 and 1, that's where these two graphs actually intersected, okay? But in order for us to find them, we have to be able to solve these equations, okay? So that's that. Now, what I'm going to do is I'm going to test a point, all right, that is in these intervals, okay? And what I'm going to do is test the truth value of those. So what I'm going to do, I'm going to test the point negative 2. That's my test point. And then I'm going to do 0, and then I'm going to do positive 2. So what I know is that negative 2 is in the interval from negative infinity to negative 1. 0 is in the interval from negative 1 to 1. And then 2 is in the interval from 1 to infinity. Okay, now when I test this point, what I want to do is I want to plug it into my original equation. All right, so I'm going to test this. All right, so I'm going to do negative 2 squared. Is that greater than or equal to 1? Okay, and I end up getting that 4, negative 2 squared is 4, is greater than or equal to 1. And so this is true. So my conclusion is that this is true. Therefore, it's in the solution set. Okay? If I try 0 and I plug that into my equation, I get 0 squared is greater than or equal to 1. So 0 is greater than or equal to 1. This is false. Okay, so it's not in solution set. Okay, and then for 2, all right, that's in the interval from 1 to infinity. And then, so I'm going to test that. So I get 2 squared is greater than or equal to 1. 2 squared is 4, so 4 is greater than or equal to 1. This is true. Okay, so this is in the solution set. All right, so that's what I've got, okay? Now, here's the deal, okay? Where it's true, okay, and I'm going to highlight where it's true, okay? It's true here between negative infinity and negative 1, and it's true here, okay, from 1 to infinity. And that's what we're looking for, okay? So algebraically, this is how we can do the exact same thing just by looking at a graph, all right? And that's how we do that, all right? So let's do the same thing, all right? This is just a very simple example. X squared and 1, okay? Those are pretty simple problems. That's why I did that up here, all right? But it's important we get our critical points. We create intervals from those critical points. Notice how that, when I make my intervals, I go from negative infinity to negative 1, okay, from negative 1 to 1, and from 1 to infinity, okay? And that's how I use my critical points to kind of divvy that up, okay? Because those are the points of intersection, all right? So now let's go down here, okay? We want to solve and graph the solution set. Oh, and graphing this, okay, to graph this solution set, here's my solution. Okay, we would put this on a number line. Here'd be 0, here's negative 1, here's 1. Okay, to do this, we would just shade this way. All right, that's how we would graph our solution set. Okay, because those are just values for x, remember, that make this part up here true. Okay, all right, so now let's take a look at the next problem. Okay, solve and graph the solution set for x squared minus x is greater than 20. So let me go in and put that in there real quick. Okay, let me put it in Desmos. All right, so I've graphed this in Desmos. Okay, I've graphed each of these parts separately, and I want to know when is my graph, going to be larger or smaller than, when is x squared minus x larger than, not larger or smaller, just larger than 20, not equal to, but just larger. All right, so if I zoom in here real quick, I'm going to highlight where that's the case, okay, and it's going to be larger, okay, on this interval and this interval, okay? And what I would write here for my solution, okay, is I would say that we are larger from negative infinity to negative 4, okay, those are my x values, union that from 5 to positive infinity, okay? And if I were to graph that on a number line, all right, here's 0, here's 5, here's 4, okay, we would shade in between negative infinity and negative 4, and then from 5 to positive infinity, okay? And again, what I'm looking for is my x values for when this is true, okay? So I'm just going to shade to kind of show that, all right, getting up to negative 4, and then anything larger than 5 is where we have that, okay? So let's do this algebraically as well, okay? And what I want to do is I want to think about the equation, x squared minus x is greater than 20, all right? So that's my inequality. Let's think of x squared minus x equals 20. Let's think of the equation. Let's just solve that, okay? And so what I have is I'm going to subtract 20 from both sides, all right? And I'm going to get x squared minus x minus 20 is equal to 0. Now I can solve this by factoring, okay? I've got x, what is that, plus 5? No, x minus 5 and then x plus 4, okay, equals 0. And so what we can do is we can do x minus 5 equals 0, and we can do x plus 4 equals 0. All right, so if I add 5 to both sides, okay, we can get x is equal to 5. And here, subtract 4 from both sides, and we get x equals negative 4. Okay, again, these are my critical points. Now, we got those just by looking at the graph as well, okay? So what I want to do now is create my table. All right, so we have our interval, okay? We have our test. All right, what did I call this up here? The test point. All right, the test, whoops. All right, and then we have our conclusion, okay? So what I want to do is break up my intervals. So my critical points are 5 and negative 4, all right? And so what I'm going to do is put those intervals up here. So negative infinity to negative 4. I have an interval from negative 4 to 5, and then I've got an interval from 5 to positive infinity. Okay, now my test point that I'm going to use in between negative infinity and negative 4 is going to be negative 5. Okay, I'm going to use the point 0 for my test point in that interval there, and then I'm going to use 6. Okay, so if I test the point negative 5, I got negative 5 squared minus 5. Is that greater than 20? So I got... So negative 5 squared. Okay, so if I test negative 5 squared is 25 minus 5. Is that greater than 20? Sorry, this is negative 5 minus negative 5. So really we're adding. So 25 plus 5 gives me 30. Is that greater than 20? And that's true, okay? So this is yes. This is in the solution set, in solution set, okay? If I test 0, 0 squared minus 0, is that greater than 20? So 0 greater than 20? No, that is false. So this is not in solution set, okay? And then if I test the number 6, okay, I've got 6 squared minus 6. Is that greater than 20? So I've got 36 minus 6 greater than 20. I've got 30 is greater than 20. This is true. So yes, This is in our solution set, okay? And that's what I got, all right? So, you know, where this is true are those same intervals, okay, that I had before, okay? And that's how I figure this out algebraically, okay? Now, here's the deal. This does take a long time to do, all right? And for time purposes, I did want to show you this algebraically, but all I'm really concerned with is your guys' ability to, you know, do this on a graph. So what I'm going to do for the rest of the problems, I'm just going to graph them, and then we're going to look at the graph and answer those questions. So here's what I got. Let me plug these into my grapher, and we're going to solve them that way, okay? So give me a second. Let me put it in Desmos. All right, so on this one, what we're looking for is when is 6x minus 1? When is this graph larger than 2x squared? And what I want to show you, and I'm going to zoom in here on this, is that that occurs between these two values, okay? When my graph is above those two, okay? And so that's going to occur in this small little area, okay, between these two values, all right? And so that's what I got. So here's what our solution set would be for this one. So our solution set would be from negative 2.823, okay, to negative 0.177. So you're just looking to see where those points are going to be above that line, okay? So that's what I got. All right, so when that graph is larger. All right, let's go to the next one, okay? Solve and graph this solution set. So let me graph this. All right, so on this one, we're looking to see when is my line x plus 3 larger than x cubed plus 3x squared. So x cubed plus 3x squared is given by this curve here, okay? And let's just find these critical points where these cross, all right? So my line is above the graph on this interval here and on this interval here, okay? So what I want to do for my solution set, okay, is I would say from negative infinity to negative 3, and that's bracket, okay, unioned from negative 1 to 1, okay? And that's what we would have, all right? That's for our solution set. Okay, let's take a look at the next one. All right, 2x over x plus 1 is greater than or equal to 1. So let me graph this in Desmos real quick. All right, so on this one, we're looking to see where the red line is larger than the blue line. Okay, now, the only time when it's not, now, before we do anything, we have to identify the fact that there is a vertical asymptote here, okay? And the vertical asymptote is at the line x equals negative 1, okay? And so, you know, what I know is that my graph is above the blue line from negative infinity all the way to negative 1. And then at negative 1, okay, we switch and it's below, okay? But then at 1, all right, it goes over like that. So this one's a little bit harder to read because of the vertical asymptote. However, all right, same thing, you know, we're not doing anything different. And then our solution set would be from negative infinity to negative 1, okay? And I'm going to use a parenthesis on that because we have a vertical asymptote that we're about to hit. And then from 1 to infinity, okay, we use a bracket from 1 to positive infinity, okay? And that's what we got. So, and I'm not going to do this problem here, okay? We're just going to skip that. But so on your homework, use your graphs, okay, to do this, all right? There is a way to do it algebraically. When you get into calculus and stuff like that, we'll do a lot of this kind of stuff. That's if you make it to calculus. If you don't have to take calculus, then you don't have to do it. But that's how we read those graphs and do that. So hopefully this made sense. And let's go ahead and get started on everything, and we'll go from there. Wait, what happened to this one? I don't know where that graph went. This graph should be, sorry, I don't know why that isn't there. Negative infinity to negative 3, okay, and then union with from negative 1 to 1, okay? Yeah, that's the solution for that one. I don't know why that didn't pop back up. So, all right, that's what I got. Hope you enjoyed this. Let's get started on everything else, and we'll see you later. Bye!